Thank you for joining. I'm Andrew Madsen. I'm head of evangelism and education, and Afzal is one of our solution architects. Afzal is incredibly experienced and just finished running our Snowflake benchmarks. And we're thrilled to go through his results, why they matter, and get a little bit of a demo.
This is kind of is reminiscent of my data consulting days, really, because, back when I was a data consultant, we had clients ask us to do vendor assessment all the time. And part of those vendor assessments, we would look at different categories. And some of those categories were around usability, scalability, cost, performance, technical aptitude of the team that's kind of required to use those products. Um, so what was really nice is, one of the things that kind of is overlooked oftentimes is just like performance, right? And being able to run a benchmark with performance on a standardized data set can be challenging. We see Databricks and Snowflake do it all the time, but of course, those are very large companies that are able to run these benchmarks very easily. Um, and going back to kind of like why we wanted to do this is we wanted to kind of show not only our current customers and prospects and users, how we operate, but we really wanted to identify some of the things around the data engineering, analytics engineering workflow, and then how that really does tie to performance. So when it comes to building data transformation at scale, building scalable, efficient data pipelines, are you using the right tool that is meant for you, for your team, your organization? So we really wanted to showcase kind of the differences between a competitor of ours, of course, but we really wanted to highlight how we do things as well within our product.
Exactly. We hear over and over again from the field and from different organizations that their teams are experiencing both inefficiency, they feel like there's bottlenecks there, but also inefficiency on the bottom line, that budgets are tight and that they feel like their cloud bills are out of control. And you were able to really dive into this and see, how can we open up these teams and free them by making them more efficient, but also help that bottom line.
Oh yeah, definitely.
And so bringing it back, so you were able to test SQL Mesh against DBT Core, the main alternative to SQL Mesh. Just at a high level, like what is SQL Mesh?
Yeah, that's a great question. So SQL Mesh is going to be our open source data transformation framework. And there's a few key differentiations when it comes to how SQL Mesh operates. I see that you've listed one of my favorite ones right there at number one, right? So we have a state aware architecture. And this is really important because no other tools on the market really have a concept of state. And the way that we do it is, we are able to track every version of every model that you create. And we know the last time you ran something and the next time something needs to run. So we will never unnecessarily reprocess or run a data pipeline that doesn't need to run. And this is a key differentiator between a lot of other tools, especially DBT Core, right? If you do a DBT run, it's just going to orchestrate and run your whole project, right? Regardless of if you just built those tables and whether or not those tables only update on a daily basis anyways, you're unnecessarily running compute. A few other things I want to highlight while we're talking about SQL Mesh, right? We have a different way of doing development, right? So we have a concept called virtual data environments. And I really love this because it just makes it so much easier to do development. These are isolated virtual environments that are fully managed by SQL Mesh. And what's really nice is if you create something within your virtual data environment, technically you created it in dev. When you want to deploy that to prod, we can reuse that same table that you created in dev. You don't have to run it and build it again. And this is where things become way more efficient, way more scalable. Imagine a team of 40 developers across the organization making changes on a daily basis, running all kinds of different data pipelines. You want to be smart about how your team is operating. You don't want them waiting around, waiting for things to just build, especially if they're creating a virtual data environment, right? That's going to be really fast. But if they don't have access to something like a virtual data environment, generally they're rebuilding their whole data warehouse or some set of a DAG, right? And that can take a lot of time. That can cost a lot of money.
100%. And one thing that folks really tend to like is our column level lineage, which you can get with other tools, but typically in their enterprise and paid products. And we were able to provide that open source. What, in your opinion, why does column level lineage matter?
Yeah. For a long time, people operated without column level lineage. So, when I talk to people, oftentimes it feels like a nice to have versus a need to have. But once you start using column level lineage, it automatically switches, right? It is no longer a nice to have; it is a need to have. So, the main highlight around column level lineage is understanding how certain metrics are being transformed, how certain aggregations are being transformed. You can oftentimes have hundreds of data sources that have landed into your data warehouse, and going from the raw to the data mart level, there are all types of joins, aggregations, all types of case one statements happening as you transform that data. Being able to really pinpoint exactly how something is being transformed end to end is incredibly valuable, because then you understand what can be used in any downstream sort of use cases, right? So downstream use cases being like your reporting, your dashboarding, your analytics, your recommendation system, any AI or machine learning use cases. Um, you really need to be able to track that. The second part of column level lineage that I think is really important is you're going to be making changes to data pipelines. So when you make changes to data pipelines, you need to be aware of what's going to happen downstream. Oftentimes, people work in a black box and they make changes to aggregations. They change net revenue or they change a different metric. That's going to break things downstream. You need to be aware of what's going to happen, and you need to have that confidence to be able to make those changes. And that's where SQL Mesh really excels, because we have a concept called impact analysis. So we'll tell you whether the change that you're making to an existing model is going to be a breaking change, non-breaking change, or metadata only change.
I love it. At at scale is really kind of when this matters because you can get along with duct tape and paper clips and glue holding everything together until you try to scale, which is what I love about our story of the foundation of our founders evaluating other products and realizing that they wouldn't scale or they'd be insanely expensive and inefficient. And then they built it from the ground up from first principles the right way, using their experience from Google, Netflix, Apple, and Airbnb. And you were able to really demonstrate that in the benchmark. So let's dive in. If you could just explain, like, what was the benchmark? How did you do it? And then maybe we can get a look at the tools that you use, take a look at Snowflake and SQL Mesh and Tobiko Cloud.
Yeah, definitely. So a few things about the benchmark that I want to highlight. We wanted to replicate what a typical data engineering workflow looks like on a day-to-day basis, right? So things like creating a development environment, making a change, making a breaking change, deploying that change to prod, kind of the most common workflows that somebody might encounter. By replicating that in this controlled experiment, or call it, the benchmarks, we were able to highlight how SQL Mesh is able to perform and where it excels side by side with DBT Core. And what's really nice about this is, we use the TPCDI benchmark data set. So again, TPCDI is this independent organization. They have these data sets that have been used for a lot of different benchmarks. Snowflake has used it to show performance. Databricks has used it to show many of their performance stats as well. So what's really nice about this is they give you a fully standardized data set for like a real life data model, right? You have your dim tables, you have your fact tables, you can pick your scale factor, meaning you can select how large of a data set you want. So we went with a 100 scale factor, so about 100 gigs of data, right? That's pretty common, pretty standard across many different organizations. So we use that data set. We essentially had all of the source tables built into Snowflake. And then we had our project where we had defined our SQL and Python models. For this benchmark specifically, we focus on SQL models, right? Just to make it easier to understand. And a few things that I want to highlight there more specifically are going to be sort of like how many models we had. So we had about 57 models, a lot of them, being full table refreshes. We had some views that were incorporated in there as well. Um, let's see, what else did we have in here? Um, I mean, those are kind of the main highlights. The other thing that was pretty awesome about this is, the first time we ran it, we actually did it on Databricks, and we had a Databricks solutions architect work with us in tandem. So when we ran it on Snowflake, we basically took the same methodology and applied it to Snowflake as the data warehouse, which was really awesome. Made it really easy to run since we had already done it that first time.
I love it. Well, let's dive in. Let's take a look at the systems and get a look at what you did and what impact that really can make, the tangible impact that it can have on organizations.
Okay, so let me go ahead and share my screen now. And maybe the first thing we can kind of dive into is let's start off with Snowflake, right? So again, for many of you tuning in, if you are familiar with Snowflake, this is going to look pretty pretty similar to what you might have dealt with when you log into Snowflake. So a few things, right? We have our database here, TPCDI. And again, this is where we had all of our sort of, raw data tables. And I'm just going to open this up a little bit so we can take a look at some of the tables that we had. Um, so these are kind of the base tables that we were working with. So we have some models around, company, dim date. We have some trade incremental. And if I click through these, we can start to see, how many rows some of these data sets have, right? So this one has, about 12 million rows. If we click into the columns here, we can start to see, what does that data look like? We can even do a little data preview if we want to take a look at what the standardized data set looks like. This one had about 54 million rows as well, so about a gig of data in this. Again, working with some really interesting data here. And now let's kind of switch over to my actual project, right? So let's go ahead and open up VS Code. All right, so can you see VS Code over here? All right, sweet. So I'm going to walk through a little bit of what this project really looks like for anyone that's maybe not familiar with SQL Mesh or even Tobiko Cloud, right? A few things to kind of highlight. We're going to have our project directory here, and this is where we will have folders for different things like audits, which we consider data quality tests, right? We have macros, we have our models, we have seeds, and really we're going to focus on the models folder here. In our models folder, for example, this is where we are going to have our actual models that we defined and a lot of the transformations that we have defined as well. So a few things to kind of highlight, we have this fact holding SQL model open up here. One of the things that I want to point out, we can define audits or data quality tests right in the model config. This makes it really easy to be able to add in audits. You don't have to manage them separately in some other YAML file like you have to with DBT Core, for example. Um, and then the other thing is, right, we are just writing ANSI SQL. So what you'll notice here is no ref tags, no source tags. We can just write plain vanilla SQL in here, and we can start to really understand exactly what's going on here. A few other things that I do want to highlight here as well. We are also here. Let's see if I can. Let me load up our. Okay. I'm going to go ahead and sign in to Tobiko Cloud here. And what's going to happen here is I'm going to open up our VS Code extension. Okay. So let's go ahead and take a look at this model again. And while that's loading, we're going to install the dependencies. A few other things I kind of want to highlight here is, again, we're working with several models here. We're doing some transformations. If I go into sort of the silver layer, you can see some of the other transformations we're doing here. We have some window functions. We're doing, cleaning up of some data. We're categorizing data. We have some aggregations in here as well. So if I go into maybe one of our cache transaction models, for example, here we have some balances, really trying to take some real life examples in here as part of the data set. From here, right, we just tested out building what we would actually do in some of the workflows. So what does that look like? So some of the more common workflows, right, we want to run a SQL Mesh plan and pass in a virtual data environment, right? So what's going to happen here is I can actually execute that plan. First thing that happens is our linter runs. So all of these are just warnings because, it doesn't like the select stars in my project. That's okay. Here we're going to see, some of the differences between my virtual data environment and the prod environment. And then from there, we're going to have impact analysis. So what I was talking about earlier, where, not only do we show you things like column level lineage, but we are also able to categorize changes as either breaking, non-breaking, or metadata only. And then we're only going to do the work that's necessary. So in this case, I made a change to dim broker, right? We can see that code diff right here. This change that I made doesn't actually impact any of these downstream models. So all I really have to do is rebuild one of these tables. I don't have to rebuild all of the downstream dependencies naively. And that's super powerful. So I can go ahead and backfill those tables, right? And here I'll get a CLI output of exactly what's going on. I also get a link to Tobiko Cloud. So the Tobiko Cloud UI has full access to seeing everything from all the plans that I'm running, all the runs that I'm executing, all the executions, all the audits that are running. And very quickly, we can see I just refreshed this one table and it's already done. Just like that. Super easy. Going back to the VS Code extension, right? Now that I have it installed, I just want to quickly show you. Look at this. We have full column level lineage within the actual VS Code frame here. This is super awesome, super easy to work with. So even as I'm developing, making changes, I can get all of this all in one place. I want to pause there. Andrew, any questions?
No, it's really powerful, and highlighting that when I explain this to people, sometimes they just nod because it makes so much sense, and they think, "Oh, isn't this how it is everywhere?" And it blows their minds when I explain to them, "No, actually, none of the other tools work this way. They do the full refreshes and the full rebuilds, and they don't categorize changes, and you end up
Mm-hmm.
paying so much more in cloud costs and compute because if you compile faster, right? If you compile 30 times faster, that's such a small part of the overall process of
It,
rerunning and 30 models that you didn't have to do. That's where the real cost savings is. Yeah, it's really great, and that lineage is so easy to work with.
yeah, I agree with you. Um, One other thing that I want to point out is, with the VS Code extension, right? Again, just highlighting all these things that the linter is able to check for, right? No select stars. Select stars are an anti-pattern. They're non-deterministic. You never know what's going to return if you end up putting a select star in there. So what's really nice is, this problems tab here, as I'm developing, as I'm making changes and just saving my code here, it's going to surface up these issues. And I get sort of instant feedback on what I'm doing here. And again, I don't have to wait for something to compile. I don't have to wait for something to execute against the data warehouse. I get that real time feedback. And that's what really makes a difference to all of these teams.
Exactly. It's a great way to instill best practices in an organization is by, having that centralized linter with excellent rules. You're able to create idempotent pipelines because you're not allowing select star in your models. It's really great. What's maybe the benefit or the difference of using a native built-in linter like SQL Mesh has versus something like SQL Fluff, which I see every now and again? Is there a big difference there?
Yeah, there's definitely a big difference there. I use SQL Fluff quite a bit. Most of the time, SQL Fluff is just kind of changing, formatting. It's not actually doing anything like pretty meaningful. Our linter actually is built from the ground up. We are not using someone else's open source technology or anything. We built this ourselves, and we have created some out of the box rules, things like no missing audits, right? So when you create a model, where you can have your developers, really follow this style guide of always adding an audit, right? But what's even more impactful is you can write your own custom linting rules just by writing some Python. So we have support for anyone to basically create their own custom linting rule. Very similar to how you could create a custom audit, right? You should be able to create a custom linting rule. So as long as you know Python, you can have uh, any sort of custom linting rule that you want your developers to follow. So you really get control and flexibility here, right? And you get to really define what your style guide is for all your developers.
I love it. And everything you showed blows my mind that it's open source, it's available to anyone. But what you also noted was that because you also have access to Tobiko Cloud, the enterprise product, it gave you a link to Tobiko Cloud, which has even more robust features. I see you're going to share your screen and show us a little bit more about Tobiko Cloud.
Yeah, so I wanted to show you all that plan that I ran, right? So again, going back to sort of the more common workflows, creating a virtual data environment or creating even a development environment, right? So what really happened there was I had the CLI output what was going on, right? It was giving me impact, it was telling me what was happening. And here I can come in and actually see, okay, this was the change that was made. This was the actual diff that was executed. I can also see the recent activity here, right? So again, really able to understand like what's going on here. If I click into the actual plan itself, we have even deeper context and details here, right? So we have something called a DAG debugger view, which I really love because whenever, problems happen and things go wrong in your data pipelines, the most challenging part is just figuring out impact, the actual logs that matter, and what I can do about it, right? Most of the time, you're spending majority of that time on the first two versus the third one, which is really just resolving the issue. So we've made it incredibly easy for you to be able to inspect, dissect, and really understand what's going on with your data pipelines. So a few things I want to highlight here is one, we give you that definition front and center. We're going to show impact. So in this case, we're going to categorize your downstream and upstream models. We're going to give you the schema here as well, so you can quickly understand, okay, these are my types, these are my columns. We're going to show you the intervals that this model is ran for as well. And then we're going to show you exactly what happened, right? So this completed just fine. But as you can imagine, sometimes you have failures. So why don't we show you what a failure looks like? In this case, I had a failure here. And now if I go into my actual error message, we can see, boom, front and center, no stack trace, no additional logs, just the real error message that matters to me. So no connections were configured. That's perfect. This is exactly what I need. So I can now go fix the actual problems and then move on with my day.
Now, what's the alternative to that? So our debugger is insanely powerful and very helpful to use, but for those who aren't on Tobiko Cloud, what does their debugging experience look like? Why is ours so great?
So a few things that we mentioned earlier, right? With Tobiko Cloud, we host your state for you. And because we host your state for you, right, we have things like a cloud native scheduler. And because we can schedule your project and orchestrate it, we know, again, when things go wrong, right? We are capturing all of that metadata, all of that information. So we can build this very robust UI and debugging experience based off of all of that information that we are able to capture. What's again really nice about this is um, we want to make sure that even when things are going right, you log in here, you spend maybe a minute or two, and you go on with your day, see the green check marks, see the freshness here. We want that same experience to happen when things go wrong too. You come in here, you spend 1 or 2 minutes, you see some red, you pinpoint the exact error, right? And then you fix it and move on with your day.
I love it. It's so great. It's such a streamlined experience. So not only is your development workflow optimized, but you're also working more efficiently with Snowflake. You're not only going faster, but you're also saving so much in compute.
Yeah, exactly. Now, the debugging experience in SQL Mesh, we have some really great UX around, displaying things in the CLI, but you won't have this DAG debugger view. You won't have this visual representation, which can sometimes be a lot easier to understand. Now, we know that people have been parsing through logs for many years, right? So people are kind of used to that debugging experience. If you are kind of used to that world of debugging, then you'll maybe miss out on sort of this DAG debugger view and getting that additional context, but it's not going to be the end of the world. SQL Mesh is still great at showing you, where the errors are, what went wrong. We just wanted to make this a more enterprise experience.
Exactly, because we're able to host more of the information, we're able to do more with that information, unlike the open source version where you're really hosting it on your own. So you need to do a little bit more on your own. You've got that trade-off there.
Exactly.
Wonderful. Well, thank you so much, Avzal. This is an amazing benchmark, across Databricks, Snowflake. The results are the same, that we're able to do things faster, we're able to do them more efficiently. Were there any downsides? Were there any gotchas that were discovered as part of the benchmarks?
Let's see. Any gotchas? Um, No, not really. We also did Tobiko Cloud as a comparison as well. So we did SQL Mesh, Tobiko Cloud, and DBT Core as part of the full benchmark paper. One of the things I do want to highlight that maybe won't be as obvious is in Tobiko Cloud, we have some advanced change categorization. So in some cases, breaking changes are going to be even more efficient in Tobiko Cloud. So that's definitely a point to highlight. Um, but otherwise, I created all the GitHub repositories where we have all the code hosted. So if somebody wants to be able to replicate this, rerun this on their own, we have the project for Tobiko Cloud, we have the project for SQL Mesh, we have the project for DBT Core, and you can see exactly what version we ran. You can see all the model code. You can download it locally and start playing around with it as well. Um, so yeah, I mean, otherwise, this was kind of expected. We know that some of the things that we have focused on and the way that we have architected the product, um, that it's meant for more efficient transformation. It's meant for more scalable, bulletproof data pipelines. So a lot of the results were actually, right as we would expect.
I love it. Well, thank you so much for running those benchmarks, for explaining them to us, and then showing the demo of both tools. For those who want more information, join our Slack channel where you can ask live questions. Our engineers are in there answering questions, a fantastic community of more than 4,000 data engineers and practitioners who are hands on keyboard. Afzal, thank you so much for sharing the insights, and we'll see you next time.
All right. Thank you, Andrew.